Hi everyone, good evening. Today let us discuss about Docker containers. But first of all, what comes to your mind when you hear the word container?
You can use Zoom chat to express your ideas. Okay.
Bucket, yeah. Uh, LG, can you? Thank you. Something to store, package to store the thing. Exactly. In layman terms, we have always heard of container as a box which has a fixed size inside which we have some contents. Here, the contents can be related to the code which needs to be executed along with the dependencies. Something like the executable along with the libraries that the code needs in order to be executed. Also, there is no dependency on the platform. So the container becomes an independent entity that can be executed by itself on any platform and with different versions of platform. Next slide, please. But before shifting to anything, we always see to the why aspect of it. Similarly, why do we need containers? We already have cloud computing in place, different service models, which we can host on applications and access it through across the globe, which makes our life way more easier. But with the pros, there comes some cons. We do face some challenges while working on cloud, which includes security and policy being the biggest challenge to cloud computing. Portability, since there is vendor lock-in. Therefore, applications cannot be migrated easily from one cloud to the other. Interoperability, which includes application on one platform, cannot incorporate services from the other. And last but not the least, high cost. Since these data intensive applications on the cloud require high network bandwidth. Along with all of these, let's say we have an application consisting of Node.js, Ansible, MongoDB, Redis, some other different dependencies and is developed. Now we have to pass it to the testing team for other rounds of testing before we do the prod push. I cannot ship my machine to that team. Also, installing these many dependencies would be a tedious task in itself, because compatibility between versions of these software is a key aspect that needs to be looked upon, leading to a lot of complications. Here, this brings into the introduction of containers. With containers, each service has its own dependency isolated within a container and with which we should be able to avoid the works on my machine scenario. Container is a standalone executable package of software which includes everything needed to run an application. Next slide, please. Here we can understand the differences between a monolithic application and a microservices application. In a monolithic application, as we can see in the picture here, it's a Rubik cube. We cannot change just one cube of the Rubik cube without changing the others, which means in order to make change in any part of the application, entire code needs to be compiled. For example, we have to troubleshoot any application. For that, we have added logging to the code just to check where the code is breaking and or to check where the desired output is not being obtained. But to run the same, we need to compile the entire code, which is time consuming for building each component of that application. Hence, we are moving to traditional architecture. Hence, we are moving from traditional architecture to microservices. We can see in the picture microservices which can be compared to the Lego blocks, which are discrete and loosely coupled. However, if we want them to talk between themselves, I mean, if we want them to have a communication between them, we can set that up using protocols. Also, in this case, if we want to make the changes in these kind of applications, we do not need to compile the entire code. Instead, we can, the single component on which we have to make the changes or which has the faulty code, that can be compiled and modified. Hence, this saves a lot of time. Next slide, please. Coming to the advantages of containers. They are fast, they are resource effective because they do not need a prerequisite of compute, storage, and network in order to run. According to the requirements, the resources are allocated and utilized in the best manner. They are platform independent because build it once and we can run it anywhere, irrespective of the platform. They offer a level of isolation as they abstract all the dependencies in a single box, and resource sharing as the resources are fetched from the host operating system, and these containers do not have any resources of their own. Also, these are scalable according to the load increase or decrease. The number of containers are scaled in order to fulfill the requirements. Next slide, please. Having said that, now we have discussed the advantages of these containers so far. So we have a question. You can type in the answers in the chat. What are containers? Are they fast, portable, OS independent, lightweight? Great. Awesome. Great to know that everyone is with me so far. LG, can we move to the next slide? Yeah. Okay. So till now we have discussed the advantages of the containers. But what about the other side? More the containers we have, more the complexities it will have. Though containers are isolated and independent, still they need to be managed. For example, to have a communication between a couple of containers, networking protocol needs to be set up. Also, these containers need to be scheduled, distributed, and load balanced. For example, in the big billion days on Amazon, where the number of users and requests increases drastically, which needs to be served, hence the load increases. Correspondingly, the resources required increases. But at the end, these resources need to be allocated from the host operating system itself. Therefore, these containers need to have these resources allocated from somewhere, and for that we need to have these containers distributed and load balanced at the right server. And someone needs to inform the container when to start and when to stop and when to schedule at the right time. Also, the data needs to persist somewhere in case of stateful applications. We do have two type of application. One is stateless and the other one is stateful. As an example of stateless application, we can see in case of OTP services, where we have to log into a website or an application using an OTP, which has just life of few minutes and we do not need it later. So this data need not be persisted. And here we can have the container started, generate the OTP and exit in few minutes. But on the other hand, if the database is containing the details of all the employees in the company, so in this case, we cannot afford to have the data loss. Therefore, we can have the container attached to a volume, say a data volume, where we can have the data persistent. And for the same, we can have a persistent volume attached to the container, which do not have any storage on its own, but it pushes the data to external storage. Hence, it is reliable. In order to achieve all of these, we have a platform, Docker, which allows users to build, manage, and deploy containerized applications and is widely used for the containers. Docker and container goes hand in hand. Next slide, please. Now let us talk about the architecture of Docker and how it works internally. As Docker is open source, we can directly download it from docker.io and get it installed on our systems. Docker follows a client-server model, which includes three components in the architecture, including the Docker client, the Docker host, and the registry. Firstly, here we have the Docker client, which can be referred to the system on which we are installing Docker and running the Docker commands. On the client side, Docker uses APIs to communicate with the Docker host and sends the instructions. In the Docker host, we have Docker daemon, which looks at the images and provides environment for the container to run. Now, each of these containers are created from a Docker image. This Docker image can be defined as a template of instructions and metadata, which is required for the container to run. The Docker image do not have any process running inside. It is a static template. So we can use it to spawn a container, and then the containers can have the processes inside it. These Docker images are managed and stored in Docker registries, which can again be public or private registries. Public registry, we do have Docker Hub, which is managed and hosted by Docker, on which one can pull the images to create the container. And at the same time, if I have created some application which I want to host it on Docker Hub, I can do the same thing. I can push it to Docker Hub and get my image stored there. The Docker daemon fetches the images from these registries itself. We can also use our private registries like JFrog. So for an example for the workflow of Docker architecture, we have commands like docker build, which is used to build the image locally on the system. We have docker pull, which is used to pull the image from the Docker Hub or some other repository to our local system. And then finally, once we have the image on our local system, in order to run it, in order to have a container from it, we can use docker run, which creates a container, spawns a container from the image which we have stored. Now again, if we do not have the image stored, let's say we have not run docker pull before, we just directly run docker run and some image name. The Docker daemon checks if we do have the image locally in the system. If we don't have it, it will fetch it from Docker Hub, download it, and then spawn the container. Next slide, please. Now, let us discuss in depth how these images are managed on Docker Hub and pulling the images using Docker. Like we have already discussed, Docker provides a public repository known as Docker Hub, which can be accessed using hub.docker.com. If we look at this snippet, which we have for pulling the nginx image from Docker Hub, currently I do not have the nginx image on my system installed. So we can use docker image pull to pull the image and the image name. Since we have not provided any tag or version while pulling the image, we can see the first comment using default tag, that is latest. So it will automatically fetch the latest image for nginx from the Docker Hub. Also, one thing we can see here that the image is not being downloaded in one go, but it is downloaded in multiple steps or layer by layer, we can say. And it also gives a SHA-256 checksum, which we can check if the file is downloaded successfully and not being tampered during download. Next slide, please. Yeah. And now that we got the image, we have to use the application. For the same, we can run docker run. Here, we are doing docker run and providing the name of the application, which can be any name. It need not be the actual official image name. It can be any application name, and it can be my name itself. And we have different flags. For example, we have -p, which indicates the port mapping between the container and the local port on the system. So we need a port for the application to run, and by default we have some other application using some pre-allocated ports, and we can have only one application running per port. So for that we need to have the free port allocated for this application. Once we see this run, we get an ID, which is the container ID, indicating that the container has started. To access the container, the system IP, that is my machine IP, along with the port provided. So here we can see in the picture in the slide, we have the machine IP along with 8080 to access the NGINX, and we get a page saying welcome to NGINX. All of these things are done within matter of seconds, and we do not have any overhead for building these images. Next slide, please. Yeah. Some details about inspecting these images. So we can use inspect to see what is inside the images, to see the description of these images and its component. It will basically give the details about directories, the file system and its layers, also the metadata which is required, and when the image tag was last provided to the image, and all the components. Next slide, please. Now let us discuss about the layered file system or the union file system. Docker uses layered file system. We can compare it with the cake which you are able to see at the right side of the screen, where each of these layers depict a different dependency installed. Let's say we have Ubuntu, but Ubuntu won't be able to serve the requirement. So on top of it, I want NGINX, and on that I want some PHP. So in this, installing multiple applications on top of one another and having it integrated inside a single container. Hence, in a single image, we can have different applications compressed and embedded into one. Each of these Docker images will reference to a list of read-only layers that represent the file system differences, and each of these layers are stacked at one another. So when we create a new container, we add a new and thin writable layer on top of these underlying stack of layers which have all the components. Any changes made to the running container, such as adding a new file, modifying the existing file, or deleting the file, that is being written to the thin layer, the upper layer. The key advantage of this layered file system is we can change the functionality of any component without changing the low level file system, which is hard to develop. Low level file system that need not be changed in order to change the other component at the higher level. Next slide, please. Yeah. Now let's see a Docker file, which is just like some other file and contains the instructions to create a Docker image. Like we have discussed before, the Docker follows layered file system. So at the base layer, we'll be having a base image, which is Ubuntu in our case. It can be Ubuntu, Fedora, Debian, or any flavor of Linux. On top of this operating system, we will be installing the applications that need to be passed to the Docker image. Now, let's say I have an application created in my system and I have not hosted it on any cloud. So to copy this application, I can use the copy keyword, which will copy the application residing from my local system to the image. Next, we can use the run command to execute the same code which we have copied in the previous step. Also, internally, CMD command is being used when the container start and the first instruction given to the container is can be given with the CMD command. Here we have given the Python script which needs to be run on starting this container. We can have any script in any language, be it be Java, Python, C++, C or Golang to be run at the starting of this container. So here, once we have written the Docker file, which will become an input to the Docker build command and create a Docker image. This image is a zipped version of all the packages, which on hitting the run command creates and runs a container. All the applications which will be defined in the Docker file will reside inside the container. Now LG will be touching upon the internals of container. Over to you, LG.
Thanks, Rida. So far, yeah, any questions until this point in the presentation, please ask your questions in the Zoom chat. So what Rida had covered about is like, what is a container, how it is built, what is the use of having a registry, and she also covered like what are the commands which we mostly use, which are Docker. Docker is the command name, and then it has a CLI interface with which we will be able to run commands. Like to build a container, we say build, and we'll tag it, we push it to the registry. It can be a public registry or a private registry, and whenever you need a container, we first take the image, and then from the image the container gets instantiated, so through the run command. And she also covered about the layered file system, which is very important in Docker to understand. So the cake image, whatever she had showed, so the base would be the operating system from where it comes. It can be Alpine, it can be Ubuntu, it can be Photon, any operating system. And on top of this operating system, each layer would be one of the software application which you are putting. And the custom software which we have, the example what she showed previously was a Python app. So the app gets copied into the containers. What it means is the moment the container starts from the image, it will have this Python application running inside it. And the Docker file is like a declarative file. It's like just like a text file. You can start writing it with these format of from where you are taking, what is the command you are writing, what is the make file you are doing, and then that gets fed into the Docker command, and we'll be able to make an image, and then from the image on demand we can create a container. And the advantage of following this declarative method is that if we build an image once, it will become platform independent. It's not like necessarily you'll have to build it for each platform. You may be on AWS cloud, you may be on GCP or any other cloud. The same image will work on them. The image just opens up. It just gets something like you can imagine like it gets untagged, places itself on top of the host, which is the platform, and then starts working. So now you have seen the applicability where we use the example which was taken was the OTP mechanism, right? So majority of the banking solutions in India have tie up with such OTP providers. They last only for 30 seconds or so. So those jobs need not persist any data. So they are stateless. So for stateless jobs, containers are good. But the perception most people have is that containers may not be useful when we have stateful applications. But that is not true. So there are a lot of stateful applications also where containers are extensively put in use. So that's where we use an external mount point or an external volume to go so that your container can store data in an external volume. With that said, we know the applicability, how it is built, what is the architecture. Now let us have some sneak peek into the internals of container. So most often this is not covered because you will have to have some understanding about your kernel and how things are built, but we'll try to keep it simple and then give some examples for you to register well with the topic. So here in this picture, if you see, the bottommost layer is again your platform. It can be your laptop, it can be a server, or it can be some software-defined data center instance on a cloud, any cloud. And then on top of it, you see something called namespaces. We'll see what namespaces are. And then the next is C groups. C groups are usually, by default, when I say C groups, I say container groups, but they're control groups. And next you have some building blocks, CPU, RAM, storage network, just like your laptop, which has a specific configuration that, my laptop comes with so and so CPU, this is 16 GB is my RAM, I have 500 GB hard disk, and my network is depending upon what network card you have, so that defines your network capabilities. And SEC comp is secure computing, we'll see about that. And your secure Linux. So this is SE Linux is security enhanced Linux. So by default, it will be enabled on systems which are using Docker. You'll have to enable it. There is a reason why it is a must. And these are your containers. It's a combination of some of the operating system, a thin layer of operating system files or shared libraries or shared objects along with the application. So that's why we call it like libraries and bin files. Let's move ahead. Yeah, so just imagine these two pictures and then you'll understand the internals of container very easily. So the first one is namespaces. So namespaces is what we call it as a layer of isolation. So this is an example which will be easy to correlate with. This is an apartment which has n number of flats, but each flat, it has a boundary, and then the resources within the flat are limited only to the flat. So if I'm in flat number 1, my resources are not available to somebody who is residing in flat number 2, though it is the same apartment. So that is where the layer of isolation with respect to resources are brought in with namespaces. So even though they all reside on the same laptop, this n number of containers, they still have limited access to the resources. But each one will feel that all these resources are mine. Like it could be lift or it could be generator, any flat in this apartment, and everybody has it. It's a shared resources. Nobody owns it. Each one will feel that it is on their own. So that is the beauty of namespace. The next one is control group. So control group, it lets you to define a access control. Again, so the files and folders in my namespace cannot be accessed by somebody else. If there is a compromise of the application, then what gets impacted is only the one that are in the tangible place, not everything else. The entire system cannot be brought down. And control groups is, you should see this. So control groups are very much like your building blocks. Like to build an apartment, you need brick, you need steel, you need some gravel, you need cement, some tiles. So control groups is the building blocks of a container, which are nothing but your CPU, your memory, your storage, network. So these are the 4 key things which has to compress into a container, because it's not just out of thin air that the container can start working for an application. It still needs some CPU. It needs an IP address to talk to the external world. It needs some storage to save its own files, its own journal files. And CPU and memory is required for computing the application, to make the application run better. And secure computing is again like the access of files is it's restricted. Nobody will be able to access, no write permissions. Whatever files the application spews out, only this application will have control. Similar application running inside another container, even if it is in the same namespace, there won't be access to, unless and until we explicitly allowed such access. And the last one is security enhanced Linux. As I said on the previous slide, it gets enabled by default. It will give a very good Linux control system for your Docker. The reason why it is required is when you have an application running on your laptop, simple example, it will have access to all the compute requirements on your laptop. It can access your full CPU, it can access your full RAM, it can see complete hard disk of your system. But if the program is malicious, it can eat up all your resources at the same time. Though you think that I have contained it, it's just one application in my app directory, but it has the ability to look at all the resources. So we'll have to box it. So that is where, and also we'll have to make sure that the application which is running in this tiny area is not impacting other segments of the code which is running on the laptop or the system. For this, we cut out some of the system calls ability from the Docker, which it can make to the host. Like it cannot change the system time of the laptop. It shouldn't, right? Nobody should change the system time. Nobody should change the NTP settings. No one should change the domain host name, like how the system joins to the domain. So access to some system call, about 33 system calls are there. So all these system calls are restricted. And the functionality of getting that restriction, instead of Docker taking care of it, it is brought in by security enhanced Linux. So that is the reason these 4 things are quite important. Unknowingly, when we use it, we may not be aware that, okay, there are some system calls which are being prevented, but all that hard work is being done by SE Linux. Yeah, so let us move ahead. I think there's a question, we'll see that. Yeah, currently, if we look at the use cases where containers are explicitly, majority they are used, right? The first one is the cloud native applications. So cloud native applications are the ones which are built for cloud. The moment we say it is built for cloud, we know that it has to be fast, it has to be lightweight, and it has to be very independent of other features. Like the monolithic application, which Rita mentioned as a Rubik cube, right? In case you'll have to change one side of the Rubik cube, lot of changes are happening. One line of code which you add for debugging an application will require you to compile the entire exe. The entire code has to be compiled so that the exe or that the sh file gets generated, or a py file gets generated out of it. So this becomes monolithic. The reason where containers are gaining more and more popularity is into the cloud native applications where you don't have any dependency or a tight coupling with another component. So these components like Lego brick, they can be lifted and shifted, and at the same time it's easy to replace them also. The as you know, right, open source, we have releases at a very fast cadence. Like Kubernetes itself starts releasing its update versions like every 3 months, and whenever there's a security vulnerability, like within days we get a patch. So in that case, our software layer, which is running on our systems or on our cloud, has to be updated very quickly to the newest version. At that point of time, we cannot take the liberty of bringing down the entire data center and then doing an upgrade workflow. So it has to be like a no touch. So when these applications are there, Kubernetes and these containers, they support something like a rolling upgrade. So when a newer version comes, what happens is a new pod gets created with a higher version, and then the previous old version pods get deprecated. I mean, they just keep getting terminated, and the new ones come in their place. And as a user, we will not even know like what is happening in the background. So it is such a seamless thing, and it will make sure that the running applications are not impacted. So that's why it's the best use case for cloud native applications. The other one is lightweight stateless apps. So the stateless applications, there are many. You can think of some web-based applications, or you can think of some operating systems which are just brought in and then do some job, and then they go. They don't have to store any information. So the primary difference between stateless and stateful is their ability to store information even after they are not there. Why we say they are not there is because these containers, right, they are not as stable as virtual machines. They would not be running forever. They just start when a job starts, and then when the job is complete, they tend to exit, so that you save a lot of resources. The other one is cloud migrations. So you know what cloud migrations would mean, right? So when you have to copy over some content, or you have to carry a stateful application in between the cloud, between origins, you need the mechanism to have a seamless migrations between these two. And because their nature of the security what they offer, and then their lightweight, the portability, and also they're not agnostic to any cloud. An image which is running on Azure, if you have a Docker file, the same container, you will be able to build it on AWS. So there is no dependency. So they have a best use case when vendors or customers do not want vendor lock-in, and then they want to move across cloud with agility, whichever is cheaper option, right? That is where they assess what is the cost of their operation which is running on a particular cloud. They see what is the cost for it in the next 6 months or 1 year, compare it with another cloud option, and then see which one weighs over the other. In these scenarios, it will be very easy for them to switch back and switch forward. And yeah, modernizing legacy applications, this we already covered as one. And the other one is database. You'll be surprised that the database is not far behind. And in containers, we have a lot of databases which are running. Database itself means that data has to be there somewhere. Even if the container is there or not, database has to be up and running. So most of the databases like MySQL, Postgres, and CockroachDB and CouchDB, so all these databases have been extensively, Cassandra, are all on containers. So you can just go to Docker Hub, hub.docker.com, and then you will be able to see these database images, and then you can pull it. The difference between a database application or a stateful application against the other one is the stateful applications come with an extra disk. That disk is called a persistent disk. So say for example, it's like I have my laptop, right? Yeah, it has only one disk, which is my home directory. But if you have a Windows, you can have something like a C directory. But if you have another disk, it can come like a D or a E drive. So similarly, when you have a database application, there'll be another E drive or a D drive kind of mapping, so that the actual data, the database related data will come onto this drive. And even if the C drive goes away, you still have the disk with the data. So it'll be easy for you to just take this disk and connect to something else and still have all your data intact. The CI/CD pipelines, it's now you can visualize why CI/CD pipelines we can use containers, because they just finish, they don't eat the resources. Once the job is done or once the runway CI completes, all the resources are led back, and again you have ample resources to start another run. Yeah, stateful applications, content management. Anybody knows what content management is? You can mention here. So this is something like a Documentum product for managing content. Yeah, WordPress is one, and for languages and all these applications you can use. Big data, and then and many people have all these together. So all of their boys like about 10%. So this is the data from a source called Datadog. And most often, at least in our experience, what we have seen is also matching the industry. So we have this data coming from the telemetry reports, which Docker will be publishing. So mostly used one is nginx, and then followed by Redis. Redis is also a database, and Postgres is a database. So Fluentd, we use it for logging. See, all these names, if you look at, right, you will find a very good landscape. You will figure out that, okay, is there there's no application which is left out, or there's no segment of an application which is left out, which is not already built on Docker. So that is a maturity level what you have with Docker. And why developers love it is because it is the ease at which you can manage. You don't have to carry like GBs and GBs of your code anywhere. It is just like it'll just pull from Docker, it'll build and then instantly give you a container. Yeah, this is hub.docker.com. So while you are here, you can just go ahead and open this on your browser page also. So you will have the containers, and then you have some plugins. Usually, whenever you are using it for any coding purpose, always use an official image. The reason, because official images come with the support. It's like a long-term support. In case we run into any issue, we can file a bug in GitHub, and then the community will address those issues. If you're not using an official image, then if there's a problem, then the support will be very minimal. So choose that, and then you can, so when the moment you click it, right, you will see an option like, Docker pull Ubuntu. When you run it, you have to install Docker on your laptop first. And then once you install it, you'll be able to pull the image and then see that actually Ubuntu operating system will start coming on your Mac laptop. And yeah, this is a quiz. Rida, you want to run the quiz?
Yeah, sure, LG. So as we have already discussed, let's go through this question. What happens if we attempt to perform a Docker build based on an image that is not previously referenced on your machine? Okay.
Yeah, answer looks like everybody is typing D.
That's true. If the image is not there, it will be fetched from the Docker hub, and then the container will be spawned. Yeah.
Right. Thank you. Yeah, and the next question we have is this.
So this is an open answer. Let's say we have a government portal where the civil services results are being declared and the load has been increased drastically. So what property of Docker ensures that the website is highly available and it won't be down?
Yeah, so this is a text answer.
We have discussed this in the advantages of containers and Docker. Yeah. Awesome.
More answers. Not everyone has answered.
Okay, we'll wait.
Yeah, scalability is one. Having persistent data is one. It means like maybe in between the session you lose out and then you want to come back and check. But at least for the time, from the time the results have been announced, the website has to be up and running till the closure, till the window close. So it has to be always working. And there is another aspect to this question, which I want you all to look at. It says it is never down. Yeah, scalability is one aspect. Correct. Yeah, you need to have load balancing so that when sometimes in some regions when the load is going up, right, and some are underutilized, you need to have this resource scheduling so that at any point of time your server is not overloaded or underutilized in different areas. Yeah, high availability is one. No single point of failure. So that we ensure using some replica sets and the auto scaling. When somebody said that actually, so auto scaling is like based on demand, you can expand or you can shrink the resources which are backing the server. Yeah, so I think everybody answered. Thank you all. These are right. So like I'll just go back to the questions which have been asked on the chat. How does Docker emulate Linux file system if Docker is running in a Windows machine? So on a Windows machine, when you have Docker, right, we have Windows containers also. So usually this Windows area is like, it's a less conquered territory because of the licensing cost and the other OEM dependencies which we have on Windows. But most extensively as a developer, we use Linux most. So on Windows, what happens is it brings in another abstraction, just like on your systems, right? You can have a dual boot bank. On one boot bank, you can install Windows. The second boot bank, you can install Linux or any operating system of your choice. So similarly, it emulates a small some layer of abstraction. So that layer of abstraction makes you think that you are actually running a Linux application on top of a Windows machine. But there is a conversion that happens. So every system call from Linux, when it goes to a Windows operating system, right, it gets converted. The system interrupts get converted, and then that is how it is able to access your hardware, your storage, your network drivers, because the entire Windows OS internal protocols is very different from Linux. It follows the pattern of how does Docker handle. Yeah, Docker has this abstraction, small abstraction wherein it does the conversion. If you notice, if you actually have a Windows machine and a laptop, and a Linux machine, and you will see that on Windows, it is considerably slow because every API call which it has to make to access the resources, it goes through n number of channels, translations, interrupts. So the syscalls, that's when it is usually on Windows, it's very slow, but with Microsoft and Docker team are working on some collaboration project to make Windows container lightweight and also fast. They're actually, the size is also very heavy for Windows containers. The next question is, Docker containers can be built or accessible only through CLI, or there is a GUI available? CLI is what we use because in the code, if you want to automate it, you use the CLI, but then GUI is used for visualization. But yeah, it's up to you, Docker dashboard. So the advantage of using Docker dashboard is like in one instance, you can see what are the containers which are running, what are the versions, are they running an outdated versions, is there new upgrade which is available, or it has some CVEs. CVEs, if it has some security vulnerability, right, like a security issue, if it has, it will also alert you saying that this particular Docker image which is running on your laptop is no longer secure. Do you want to upgrade it? And yeah, thanks, Pavitra. That is hub.docker.com. You can create a login and then you'll be able to push also. Without login, you'll be able to only pull the container. But once you create a login and then you have your own space, you'll be able to push your own containers, and you have an option to make them public or you can keep it private. Interested to know more on how application level network protocol is handled in the Docker. Does it directly speak with the NIC or it speak NIC via host? Docker is again, there are two types, right? One is on the bare metal you can install, the other one is hosted. So bare metal one is not not useful at all because it eats up the entire resource. The one on the hosted operating system, whatever you have, that will be talking via the NIC. So it will be talking to your external network via host OS. And we in Docker, we also have something called a POS container. So that will be actually responsible for talking to the network adapters, network cards, and understand based on the MAC of the operating system how it works, and try to get another IP address for your Docker image. So on your laptop, when you do IP config all or IF config all that, you'll also see an IP address for each of your container. You can also see with Docker PS. That command also will tell you what is the container ID, from how long it has been running, and additional details about the container. And the next question is, can we limit resources access to container? Yes. For example, if you run a virtual machine, we can allocate. Yeah. So this is where we have that SECOM, the secure computing will help, wherein even though your laptop is running like full scale of all resources, right, you can actually, your container will not see everything. So in the namespace itself, you can define that these are my resource quota. And then when you build it, it will be seeing only a portion of the resources instead of using up the entire structure in the laptop. Yeah. Yeah. Any more questions?
Hey, you can feel free to unmute and ask if you have any questions.
Yeah, and also I have a.
Yeah, LG, we have a question on the chat.
Yeah. Speaking via how the optimization that application host is not updated. Optimizations. Containers do not directly use this TCP. They only are UDP. So they are at layer 2. So this question, so even though it is running on the host operating system, right, they will still be able to have this optimization with the network. The protocols, their way they have built with AppArmor and some other internal kernels is that with UDP you will be able to have the best optimized application. But I mean, no one runs one container on one laptop, so it is again like a multiple containers run on the same thing, right? So that is how at the application level the optimization is taken care of. Yeah, and these are the resources. Actually, we wanted to show you Katakoda also. So besides the Cube Academy, which VMware has done extensive talks, they are like 101 talks, small ones like 5-minute videos you have. And that is a good resource for you to start. Next is docker.com, and CNCF is Cloud Native Compute Foundation. The fourth one is Katakoda. So in case you don't have Docker installed on your laptop, you can just go to this Katakoda, and then it will spin off a virtual environment for you where you can try various quizzes. Like you can see how to build a container, and then how to write a Docker file, how to push an image to the registry, and then everything about the Docker container life cycle. But besides just Docker, you also have AI/ML courses, you have data science courses, you have Kubernetes courses. A number of things you can find it in Katakoda. So you can go to this website. You take a picture of this if you can. And the other one is in GitHub Docker. So Docker is open source. So usually whenever it's an open source, right, it's easy for anyone to just see the code, how it is built, what are the newer versions which are coming. Usually when we have bugs also, right, the bugs gets reported on GitHub. So it is so that's when it's very important for us to start contributing to open source also. When we are heavily using Docker, we should also find means of contributing to open source, because if there is a bug which has come, we can't wait for community to prioritize it and then fix it at the rate at which you want it to be fixed. So that is when all of you, I would request you to start contributing. So initially you don't have to start writing code, but at least when you try something, things don't work, file a bug, contribute to documentation, see how the payloads are coming, what are the new features which are there. And and anything you do on GitHub, it goes a long way. It is something like your LinkedIn profile only. So along with your name, your GitHub profile gets onto your resume, and people will see what contributions you have done over a period of time. Most often, even college students we are engaging with, so we are asking them to start getting onto the open source, because whatever you do on open source, it's not just one city or one state or one country which is seeing. Your contributions would be visible worldwide. As a corporate employee, whatever you do is visible only within the walls of the corporate. But with open source, it's not like that. And it's just one license agreement you'll have to sign, and then you can become a part of it. Think on these aspects also to contribute to Docker, to Kubernetes, and there is a lot of support within India. And finally, yeah, that's all. I think we are at time. Just 2 more minutes we have. Yeah, and thanks Shubhanjali and Pavitra for having me and Rida today.
Thank you. Sure. Thank you. I think Giridhar, you had a question.
Yeah. So, hey, could you hear me?
Yeah, Giridhar, we can hear you.
Yeah. So I think I framed my last question not properly, so I think it gave a wrong meaning to what actually I wanted to ask. So one of the advantages that you said for Docker is you can mix the Linux OS or the Docker based OS. Docker's OS would update faster, and if you want to have a latest OS, instead of updating your whole data center, if you're just having Docker, you will just update one pod and you would be on the latest OS. So my question is on those lines, like if let's say you're not updating the actual host OS, but then just the Docker OS. So if there is some optimization that had been written on the network layer on application level protocols, and if you're just speaking via the host, and if the host is not yet updated, what meaning does it have in any network level updates that happen on that OS?
Yeah, now I understood your question. So usually the rate at which we update host OS is less as compared to the rate at which you update Docker. Like Docker images, every month we'll be pushing a new one, right? Whenever there is a vulnerability. But how often the host one gets updated? So we don't mean that it's not required at all, but it's not as frequent as your Docker updates. But at one point of time, what happens is the backward compatibility will break. That your Docker containers are moving fast, but in order to have this have the application performant, it is very important that we are on par with the HCL, the hardware compatibility list or the driver list, which is on the host operating system. So host operating system also will have to go through the upgrades or patches, or it has to go through some maintenance window, but it is not at the same rate at which you'll be updating the Docker. Especially in cloud, right? We are usually 6 months behind for updating infrastructure, unless and until there is a vulnerability. But your application will be running faster. Like in a day, almost 10 to 15 times we'll be updating our applications.
Thank you.
Okay, I think we are on time as well. So thank you so much everyone for your active participation, and we are very happy to announce that Women Who Code Chennai is a community partner of KCD Chennai Kubernetes Community Day event, which is coming up. So we would encourage you all to register for this event. The link is pinged on the chat. And you have a few more links that we have shared. So please share with your passionate individuals on Women Who Code Chennai chapter and encourage them to be a part of this. And for any suggestions, and if you wish to be a volunteer of this chapter, please send an email to chennai@womenwhocode.com. We'll definitely reach back to you. And yeah, so we have a Women Back to Work program in VMware, which is a VM Inclusion Tara. So the link is given on the chat. So please explore that and encourage all the women who have a career break so they can make a use of this opportunity to get back to work. So I think we are almost on time. Thank you so much, LG and Rita. It was an absolutely great session. And I think everybody would have definitely liked the cakes and the buildings that you shared. So it was really interesting. And yeah, thank you so much for making it interactive, guys. Thank you.
Yeah, thank you. Thank you,
Thank you.
LG.
Thanks all.
Great.
Bye. Have a good weekend.
Thank you all.
Bye.
Bye. Yeah. Bye.